So today's lesson, lesson 5.3, I can solve systems using substitution. Now remember, this is just an extension of what I went through with you on Friday. So let's start off with the I can statement. I can solve a system of linear equations using substitution. All right, so this first example, example 1, says consider the system below and its solution, x equals 4 and y equals 1. The system, 2x plus y equals 9, and y equals x minus 3, we're going to show that 4, 1 is a solution to the system. So we do that by just substituting in the values of the variable. So this is my x, and this is my y. So I want to show that this is a solution. I'm going to start with 2x plus y equals 9. So I'm going to replace the x with a 4, substituting in the value, and I'm replacing the y with a 1. So 2 times 4 is 8. So I have 8 plus 1 equals 9, and 8 plus 1 is 9. So 9 does equal 9. Remember that you want to check and make sure it's a solution for both equations in the system. So our second equation, y equals x minus 3. I'm replacing the y with the number 1, and I'm replacing the x with a 4. 1 equals, let's see, 4 minus 3 is 1, so that is true. So we've just shown that the solution for 1 is a solution to the system. So now we are going to substitute in the expression. We're substituting in the expression x minus 3 for y in the first equation. So the first equation, 2x plus y equals 9, we are replacing the y with the expression x minus 3. So 2x plus x minus 3 equals 9. So 2 times x plus x minus 3 equals 9. 2x plus x is 3x. 3x minus 3 equals 9. Add 3 to both sides. 3x equals 12. Divide both sides by 3. And I find out that x equals 4, which is exactly what we were supposed to get, right? When you solve it, you should show that the value of x equals 4, and we just did that. So now we're going to solve the other part of the system. We're going to solve for y by using the other equation. So we're going to use the equation y equals x minus 3. Y equals x minus 3. And we're going to plug in or substitute in the value of 4 in for x. So y equals 4 minus 3. Well, that means that y equals 1. So the solution to the system is 4, 1, which is exactly what we were told in the beginning. Okay, go ahead and turn the page. So an important idea of substitution is that equals can always be substituted for equals. So I see in this first system that y equals 2x plus 5. Sorry about the extra plus sign there, but y equals 2x plus 5. I also see that y equals negative 3x minus 10. So equals can always be substituted in for equals. So really what I'm going to do is I'm going to take the 2x plus 5 which is the value of y from the first equation, and substitute that into y for the second equation. So that gives me 2x plus 5 equals negative 3x minus 10. I'm going to add 3x to both sides because I'm solving for x. We use substitution because we eliminate one of the variables. Remember, you cannot solve a two-variable system unless you can't solve for two unknowns, right? So by eliminating the y variable, we're only solving for one unknown. We're just solving for x. I'm going to subtract 5 from both sides. 5x equals negative 15. Divide both sides by 5. And I find out that x equals negative 3. So I'm going to take this value, x equals negative 3, and I'm going to plug it into, or substitute it in for the second equation, y equals negative 3x minus 10. So I'm going to replace the x with negative 3. So I'm substituting in the value negative 3 for x. Well, I know that a negative times a negative is a positive, and 3 times 3 is 9. So I end up with positive 9 minus 10, and 9 minus 10 is negative 1. So the solution to my system, which is an ordered pair, is the ordered pair 3, negative 1. Now, it's important that you always check your solutions. It's important that you always check your solutions. So I'm going to check the ordered pair negative 3, negative 1 in both equations and make sure it works. So my first equation, y equals 2x plus 5. Remember, I'm letting y equal negative 1, and x is negative 3. Well, that means that negative 1 equals 2 times negative 3 is negative 6 plus 5, and negative 6 plus 5 is negative 1. I have to check both equations. I need to make sure that my system works, my solution for my system works in both equations. So now I'm checking the solution negative 3, 1 in the equation y equals negative 3x minus 10. So I'm replacing y with negative 1 equals negative 3 times negative 3 minus 10. Negative 1 equals 9 minus 10. Negative 1 equals negative 1. So here I've just shown that my solution, negative 3, negative 1, works for both equations. All right, example number 3. Max and his father, Kirk, are comparing their ages. They know that the sum of their ages, so sum is an addition problem. We know that the sum of their ages is 52. We also know that Kirk is, the word is means equals, 7 years older than 4 times Max's age. So M represents Max's age and K is Kirk's age. So we're going to write a system of equations that models the scenario above. And whenever I write a system and I find my solution, I try to always put my solution in ABC order, meaning my ordered pairs are in ABC order. So K comes before M in the alphabet. So when I name my solution, I'm going to write it as K, comma, M. So let's see, let's write a system. The sum of their ages. Well, that means that Kirk's age plus Max's age equals 52. Okay, that's good. But then it says that Kirk's age is represented by the letter K, and the word is means equals 7 years older than, so that's 7 plus 4 times Max's age, 4M. So this is the system that I'm going to use to figure out the ages of Kirk and Max. So I'm going to let the 7 plus 4M replace the value of K. So 7 plus 4M plus M equals 52. So all I did was replace the K, Kirk's age, with the 7 plus 4m. Doing this has allowed me to eliminate the K variable. So now I'm going to simplify. So 7 plus, well, 4m plus m is 5m equals 52. Now I'm going to subtract 7 from both sides. 5m equals 45. Divide both sides by 5. And I find out that m equals 9, which means that Max is 9 years old. Let's see if we can figure out Kirk's age. So Kirk's age is represented by the expression 7 plus 4m. But we know that m, Max, is 9. So I'm going to replace the m with a 9. 4 times 9. And I know that 4 times 9 is 36. So I have 7 plus 36. This should be an equal sign. 7 plus 36. That means that Kirk's age is 43. So Kirk is 43 years old. Lastly, I'm just going to write this ordered pair, the solution. K is going to come first, 43, comma, 9. Okay, example number 4. So sometimes you're going to be given a system in terms of a table, right? So 2 cell phone plans offer differing text packages. They're outlined in the table below. So the plans, the easy plan, has a monthly charge of $9.25, and you're going to pay 6 cents per text. The budget plan has a monthly charge of $2.50, and you're going to pay 15 cents per text. Well, we know that that word per sounds like slope. We know that per, each, every, that's a slope word. And we know that a monthly charge is our beginning fee. So we are actually going to write both equations in the form y equals mx plus b. So I'm going to let the total cost, y is going to equal the total cost, and x is going to be the number of texts. So let's see. If I think about the easy plan has a total cost. Y equals, well, my monthly charge, 9.25, plus my cost per text, 0.06x. This is the easy plan. The budget plan has a monthly charge, so my total cost is my monthly charge, $2.50, plus a cost of 15 cents per text, and this is my budget plan. So I want to solve this. So I am just going to take this value, 9.25 plus 0.06x, and substitute it into the second equation for y. So 9.25 plus 0.06x equals 2.50 plus 0.15x. So I'm going to subtract 2.50 from both sides. 6.75 plus 0.06x equals 0.15x. I'm now going to subtract 0.06x from both sides. So 6.75 equals 0.09x. Lastly, I'm going to divide both sides by 0.09. And I find out that x equals 75. So is there a certain number of texts when the two plans will cost the same? Yes. The plans cost the same after 75 texts. Well, what if you were asked what that cost was? What is that cost? Well, that just means you need to find out what the value of y is. So I'm going to take my first equation, the one that represents the easy plan, and I'm going to substitute in 75 for x. So y equals 9.25 plus 0.06 times 75. And I'm just putting this into my calculator, and I find out that y equals 13.75. What does that mean? So that means the cost of each plan with 75 texts is $13.75. Okay. All right, let's take a look at our last example. Example number 5. So example number 5 just asks us to solve this system using substitution. The only problem is I don't have a variable isolated. I don't have one variable all by itself. But when I look at this equation, x plus 2y equals 11, I see that I can quickly solve this equation for x. And I do that by subtracting 2y from both sides. So when I subtract 2y from both sides, I have x equals 11 minus 2y. So now I have a variable isolated. I know that x is the same thing as the expression 11 minus 2y. So I'm going to take that and substitute it into the original equation, the first equation. So 3 times x, which is really 11. Excuse me, which is really 11 minus 2y minus 4y equals 18. So I have to distribute in order to get rid of this parenthesis. So 3 times 11 is 33. 3 times negative 2y is negative 6y. Minus 4y equals 18. So I'm going to combine my like terms. I have 33 minus 10y equals 18. I'm going to subtract 33 from both sides. Negative 10y equals negative 15. Divide both sides by negative 10. And I find out that y equals 3 halves. Y equals 3 halves, which is the same thing as 1.5 if you're using your calculator. Okay, these are the same thing. These have the same value. So now I'm going to take the value of y equals 3 halves, and I'm going to plug that into the second equation. So I'm substituting in the value of 3 halves for y. So x plus 2 times 3 halves equals 11. That means x plus, well, 2 times 3 halves, the 2's cancel out. X plus 3 equals 11. Subtract 3 from both sides, and I find out that x equals 8. So my solution to this system is the ordered pair 8, comma, 3 halves. Now, I want to check this. I want to check. So I'm using the solution 8, comma, 3 halves, and I need to substitute those values into both equations. My first equation, 3x minus 4y equals 18, and my second equation, x plus 2y equals 11. So let's substitute in the values. I know that x is 8, so I have 3 times 8 minus 4 times 3 halves equals 18. Well, 3 times 8 is 24, and 4 times 3 halves is 6. So I have 24 minus 6 equals 18, but 24 minus 6 is 18. So 18 equals 18. I get a true statement. Let's check the second equation. So x is going to be replaced by the number 8. So I have 8 plus 2 times y, which is 3 halves, equals 11. That gives me 8 plus, remember that your 2's cancel out, 8 plus 3 equals 11. And 11 does in fact equal 11. So this is your your 5.3 journal, solving linear systems of equations using substitution. Make sure that you glue this into your journal.